Okay, so the tangent line just uses the function value and the first derivative value at a number. When we do Taylor approximation, we're going to be looking at a number, but we're going to be taking higher derivatives. So we're going to be using more derivative information than just the first derivative and the function value. And there's a formula for this, which is that the nth degree Taylor polynomial at x equals c is going to be given by the sum from k equals 0 to n of the kth derivative of f evaluated at c divided by k factorial times x minus c raised to the k. So in other words, all you need to do to find the kth coefficient, or the coefficient on x minus c raised to the k, is to take the kth derivative, plug in the number, and then divide that number by k factorial. So let's see what this would look like if we want to find the second degree Taylor polynomial approximation of h of x equals e to the x at x equals 0. We can write this as t sub 2 of x is equal to a sub 0 plus a sub 1 x minus 0 plus a sub 2 times x minus 0 quantity squared. This simplifies to t sub 2 of x is equal to a sub 0 plus a sub 1x plus a sub 2x squared. And now we need to find the coefficients, a sub 0, a sub 1, and a sub 2. So let's go through this process. Because this is second degree polynomial, at x equals 0, we know that we can write out the general form as t sub 2 of x is equal to a sub 0 plus a sub 1 times x minus 0 plus a sub 2 times x minus 0 quantity squared. And now our job is to find a sub 0, a sub 1, and a sub 2. So now we know that that coefficient a sub 0 is just equal to the number plugged into the function. So that's h of 0, which would be e to the 0, which would be 1. Now, the next coefficient, a sub 1, will be h prime of 1 divided by 1 factorial, which is just 1. So that's going to be, that should be h prime of 0. E to the 0 divided by 1 factorial, which will be 1 over 1, which is 1. And finally, a sub 2 will be h double prime of 0 divided by 2 factorial, which will be e to the 0 over 2, which will be 1/2. So these are the coefficients that we need. We found our a sub 0, a sub 1, and a sub 2 values. Now we just need to plug these things in. So we get t sub 2 of x is equal to 1 plus x plus 1/2 x squared, and that would be our second degree Taylor polynomial approximation to e to the x at x equals 0. Now it's a pretty similar process if we were trying to find a fourth degree Taylor polynomial approximation of h of x equals e to the x at x equals 0. It's just that now we're going to have 5 coefficients. We need to find the values of a sub k from a sub 0 to a sub 4. So after we plug in and simplify, we get that the general form here will be a sub 0 plus a sub 1x plus a sub 2x squared plus a sub 3x cubed plus a sub 4x to the fourth. And our job is to figure out these a sub values. Now because this is a Taylor polynomial, we know what these are. This will be h of 0 divided by 0 factorial plus h prime of 0 divided by 1 factorial, all the way up to the fourth derivative, h quadruple prime of 0 divided by 4 factorial. Now let's see how we would find these values. Now I'm just writing out here the formula for a Taylor polynomial centered at 0, and now I'm going to work through and think about what these coefficients are. I'm going to simplify some of these factorials because 0 factorial is 1 and 1 factorial is 1 and 2 factorial is 2. So it's worth taking a moment to look at what some of these things are. 3 factorial will turn out to be 6, but I'll leave it like that for now. So let's take our time, and now let's look at how do we find these higher derivatives so we can plug in 0. So it's helpful to remember that e to the x is its own derivative. So the pattern in finding these higher derivatives here is not too bad. Actually, all of the derivatives are equal to e to the x, from h prime of x all the way up to h quadruple prime, the fourth derivative. Now we're going to take this information. I know that e to the 0 is equal to 1, so taking that, I'm going to get 1 plus 1 times x plus, and that should be plus, not equals, 1/2 x squared plus 1 over 3 factorial is 6, so 1 over 6x cubed plus 1 over 24x to the fourth. So here's my fourth degree Taylor polynomial approximation, and I hope you followed the process that we used to find it. Now it's also important to sort of understand what this means. So we're typing out this polynomial, and here I have the second degree approximation in purple. I'm sorry, the second degree approximation is in blue, and I'm going to make the fourth degree approximation in orange. The original curve is in red. And so you can see that that orange curve and that red curve fit really closely together. This is a very good approximation, and it would be a lot easier to use this fourth degree polynomial to get numbers close to e to the x, close to x equals 0. In general, the more terms that we take from a Taylor polynomial, the better the approximation will be.